So basic commenting practices, demonstrating understanding by making code readable. Because I want to approach the topic of commenting practices in a strategic manner, we need to recognize that the strategies we would apply to low-level coding vary from how we comment high-level languages. However, the goal is always the same. Good commenting always augments your code, making it more readable and more understandable. Low-level programming languages are those languages that are a lot closer to how the computer thinks. In other words, low-level languages do not abstract the machine reality of the computer processor. With low-level languages, we are required to be more concerned with how our instructions are ordered, how memory is set up and accessed, and even how the data in that memory is interpreted. This is because at its core, the computers are a purely numerical reality. Computers only know numbers, so everything at a low level is thought of through the lens of arithmetic or basic math and logic that is also predicated on comparing numbers. The computer does not know what a character or a string is. It just knows that we have some value and that we want to work with it. Therefore, low-level languages tend to not be flexible in how they handle memory. We often think of this as being strongly typed, meaning that the data is always stored in the same way, and it is up to us as programmers to interpret that data in the form that we intend. It is up to us to tell the computer that the number we put in that byte is meant to be a character. The computer does not naturally do this. The net effect is that low-level languages are often not very readable. There are often many steps, even just to get a character to appear on a terminal window. So it makes commenting essential. Nothing is worse than writing a driver for a piece of hardware and you don't touch it for a couple of years. The hardware updates, you have to go in and touch it, and you just can't figure out what the heck's going on. So I'll show you an example of that in a bit. The typical pattern, though, for assembly language is that you actually put a comment with every line of code. Very small comments on each line, and I'll show you why that is. And that can be overwhelming at first, but once you've had to revisit code a few times, you become a believer in the documentation process. Thankfully, modern languages, especially those that owe a debt to C and its predecessors, provide us with a way to structure and write our code that is closer to how humans think. C is a good example here because it is a low-level language, meaning that we're responsible for things like how memory is treated. And with C, we can deal more directly with the machine itself on the machine's terms. But it's also a higher-level language than assembly language, and it does provide us with tools that abstract the machine reality from us. Languages that are built on C, usually by adopting a C-like syntax, can give the illusion that the computer can be flexible with data types, and even make decisions that do not seem purely mathematical in nature, comparing words, for example. These languages are also adapted to programming paradigms such as object-oriented programming, functional programming, natural language programming, procedural programming, and a host of other different ways of approaching programming, each of which is an effort to organize code so that it is easier to read and understand. So as such, higher level languages give us a lot of flexibility in terms of how we write it. And for most high-level languages, the code itself becomes a form of commenting. That is, if it is done well. This does not let us off the hook in terms of commenting. It just means that we can use comments to augment what code is already doing. And the emphasis in commenting can be on blocks, especially in high-level languages, on blocks of comments that explain how sections of code are meant to work and meant to interact with the rest of the code in our programs, which is actually has some benefits academically. So let's just take a look at a couple examples just to show you what I mean. So let's start with assembly language. This is a small part of a library of string functions that I actually get students to code in my ARM assembly language course. It's a nice to have function that I actually don't expect students to write. We write it together in class. Notice that the instructions, they seem pretty esoteric. Even if we can understand that line 33 moves the value of 0 into general register 3, unless you have that comment, you have no idea why. And so the comment tells us that it's a counter for the place in the number. So hundreds place, tens place, ones place. And without that comment, it really doesn't mean anything. The code snippet has two types of comments. So each function in this library will have its own block comment. The goal of the block comment here is to tell users of the library what the function does, what it requires to work, and what kind of results are expected to be returned. So in this case, the function takes a value in register 1, and if it's a number less than 1,000, what it'll do is it'll return a null terminated string, and it puts that string into the memory that starts at the address in register 2. So here we see that we're passing in pointers, and it's just kind of fun once you get in there. The user of this library does not need to know what's going on inside the function. They just need to know what they need to send in and how to use it. Each line of instruction in assembly language typically has a short inline comment. So I'm using GCC assembly here, so the symbol is an @ symbol. But if you're coding in Kiel, for instance, you would have a semicolon. So all languages are a bit different, but all languages will have the ability to add blocks of comments and inline comments, even if the blocks are made up of a collection of inline comments. Notice that the inline comment explains why each instruction is done. So in line 33, the comment of put 0 into register 3 is not really an augmentation of the code. It's stating what we already know. We augment the code by saying that why we're putting the 0 into register 3. So we're creating a counter and we're initializing it at 0. We want to keep our comments terse, and when we have to modify a function, they're going to be gold. They're going to help us to navigate around. So I want to also identify a few types of comments that are helpful in higher level coding. And there's 3 types of commenting in just the start of my cards.h library file. So I've used a block comment to identify the library that I'm building. So I briefly define it and I acknowledge that I'm the creator of the library. You can add other details here, but the augmentation is that I can quickly go to the top of any source code, see who worked on it, and know what it's meant to do. I have used inline comments to organize my code. These are my include guards, that's the section here, which are simply preprocessor directives to ensure that I only include the other libraries one time in my whole program. So I just want to mark that that's what this section is doing. I would use a similar section comment to note my constants and even my object definition section. Organized code is always much easier to work with, and developing patterns of coding will help your code to become more readable. And there's another form of coding in this snippet. It might not be so obvious at first, but the flexibility of label naming form what is sometimes called natural commenting, meaning that just reading that label, I can know what that piece of code is doing. So let's actually scroll down a little bit to a deeper part of this code to see a little bit more of how commenting works. Notice that unlike assembly language, each line does not require a comment. Only include a comment. This is the rule if it adds to the readability and the understandability of the code. Otherwise, you end up with cluttered code, which is actually harder to follow. In this example, I use naming to provide readable code, and I just need to explain what each chunk or section of code does. So I include a block comment that tells me what this, in this case, it's an object, what this object is all about. And I'd also include a similar block comment on procedures, functions, subroutines, methods, anything that's complex and has to be explained. So this particular block comment should describe the object, and it should list any expectations about the object or arguments that need to be passed into, say, a function or a method, and they need to talk about what's returned and what is the significance of what is returned. So if it returns an integer, what does that integer mean? In this example, I make sure to mention what a default constructor of the type deck will create, a 52-card deck of playing cards in 4 suits. Inside the object or inside a function, inline comments are a great way to introduce blocks of code. So again, it's this organizational aspect. But it's organizational and it explains what they're doing. So in the example, I have a section of private members starting with two variables, a deck size, which we're going to use whenever we want to set or reset the deck, and a vector of card objects, which will be the deck of cards. Inline comments like this are often best derived from your pseudocode, so ones that just say, this is what I'm trying to do. Or from our flowcharts or algorithms, however you are doing the pre-work, but you're going to identify the steps that you need to code. The rule of thumb, though, is that a comment should augment your code. So, saying that our comments should always augment our codes, we can ask ourselves a couple questions. First, does this comment improve the readability of my code? Comments should be laid out consistently and non-intrusively. They should continue the conversation. Most modern languages do not care about spacing, so you can actually space it out with as much white space as you need to make your code easier to read and your comments easier to see. The second question we can ask is, does this comment improve the understandability of my code? So just because your comments are neat and tidy does not mean that your code is understandable. To use comments effectively, the comment should describe not what the code says, but what the code does in relation to the algorithm. In academic contexts, and this is where it's a boon for you, your professors are assessing understanding. Comments go a long way in demonstrating understanding, and if you can comment well, then even if your code doesn't work perfectly, we can at least see that your logic is correct and give you partial marks, or we can adjust where maybe it's your logic that's the problem and not your coding ability, so that we can give you better, more accurate feedback. If you're not commenting well, then you're actually robbing yourself of the opportunity to learn. The thing about coding is that programming languages give us a lot of flexibility, and that can get us in a lot of trouble. So having a good feedback process now will actually help you to avoid some of the common pitfalls that new programmers experience. And you could also ask this question: does this comment describe what I am intending to do with my code? So I want to wrap up with a summary of these various types of comments. So every piece of submitted code that you work on should have a header comment, which is typically some kind of a block comment. The style is up to you, but be consistent and make it readable. Like, I remember when I started out, I used to like make boxes of stars. I'm not so big on that now. I kind of find that the clean, simple look is a little more readable. Comments are always going to be unique to you. So if you submit code with identical comments, that usually indicates a problem that the instructor will investigate. So just a heads up there. In this comment block, you should list the names of any programmers who have worked on the code, and especially include your name. Indicate the file name and give a brief description of what that code is meant to do. Is it a library of string functions? Name it accordingly, and you can even list the functions with a short sentence describing each. Your professors will also have other requirements. As a programmer, you're expected to have good attention to detail, so always defer to those instructions. In the workplace, you will have commenting strategies and standards, and you're expected to follow them, especially in a team environment. Oh yeah, need to advance the slide. Okay, so organized code is much easier to work with. So if I need a bunch of constants, I'll include a comment header that tells us what they're there for. In my cards library, I created a bunch of card-related constants to make my code more readable. And I grouped them into the library's namespace and gave them headers like constants to represent card suits. So you can use block comments here if you like, but usually these comments should be single line, so inline commenting often works great. Functions and objects are augmented by a nice block comment at the top. I'm showing a different style here, though, to remind you that the format is really up to you. I often create a block at this level just with a stack of inline comments. So think of these comments as introductions to your object or to your function. In an object, I usually detail what it is for. any private members, and what we can expect from a default construction of the object. For functions and methods, it's also an introduction that describes the function, explains the arguments that have been passed into the function, and describes how the function either changes the object's state or the meaning of any values that are returned. For many functions, this might be all the commenting that is required. Note that certain methods do not usually require much commenting. For example, setters, getters, constructors, deconstructors. It's only the more complex versions of those things that actually require some more explanation. But what is always helpful, though, is to group these methods so that you can easily find them when you need to modify things. So if I want to look and see that all your constructors are there, I should be looking in one place, and it should be clearly identified. An organizational comment is ideal for this purpose. So inline comments should be used to enhance the readability of your code. Such comments explain short code blocks. In the example, I'm using the comments inside the code block at the same indentation level as the block it refers to. A great strategy for this is to take the lines from your algorithm, your pseudocode, and plop them right into your code, right into the editor. Turn them into comments, and then you have a guide to program. You can program each one at a time. If you put the code down, you're not lost. You come back and you go, oh, I have to do this one next. The big thing, though, with all commenting is to be consistent, to be concise, and use alignment to your advantage. The formatting of comments is part of the augmentative nature of the comments, and poorly formatted comments can actually make your code less readable. So you should feel free to over-comment. You shouldn't be worried about over-commenting because all of the comments are actually removed during the compilation process, well, except for debugging, but that's a whole other story. But anyway, either way, they do not incur any kind of a performance hit. The only time too much commenting is a problem is when you clutter up your code and make it unreadable. And in most modern languages, the final form of commenting is what we call natural commenting. That is when we use meaningful label names for our functions, objects, constants, and variables. In the example, I have a set of constants that I will use with the card objects. Reading the word spade in my code is a lot more meaningful than just seeing a 0 there. To make your code readable, you'll need to adopt a consistent naming convention. Note that languages often have a convention associated with them so that you can easily identify them in environments where you use multiple languages. So think about web development. Often you'll adopt one standard for PHP and another standard for JavaScript, just so that you can quickly tell what code you're looking at. And also in every workplace, there will be naming conventions. Often the local variables are up to you as the individual programmer, but anything that reaches beyond the scope of the local context should adhere to the standards of the rest of the code base. And in fact, the team lead will often enforce that. This is okay as a constant, but you need to use this naming convention. And I have my own preferences. They're simply that, preferences. You need to do what works for you, what makes sense for you, but be consistent and make your names of your objects and things, anything you're naming, all the labels, make it meaningful. Do not use the variable a when what you mean is number to add. There are some classic examples for naming variables that are exceptions. Lowercase I actually stands for iteration, and so in for loops it's used usually in the outer loop, and then inner loops can either use I, or J, K. But because these variables are part of the construct and they're local to the loop itself, and they go away quickly, it's an acceptable practice. Additionally, X, Y, and Z are used for graphical coordinates. There may be others that get used in your environment, but exceptions are rare. One final note is that label naming is often case sensitive. So being consistent, say for instance, if I always use camel case, which is always start with a small letter and every new word in my name starts with a capital letter. If I'm consistent that way, then I'm not going to get tripped up when I'm typing out things into my code later on. because you can use the same name but vary the case, and it can mean something quite different. So to summarize, comments are meant to augment your code. Code should be neat and tidy, well organized, easy to follow. And following a good naming convention reduces the need for excessive commenting. I hope that this has been helpful. I'm hoping it'll set you on the right path for an enjoyable career in programming and a successful time in our course together. Thank you.